Okay, ladies and gentlemen, our lesson today is on 1.2 linear measure, and we're going to be talking about how do we take a line segment and how do we find missing lengths on that line segment. So it should be fairly simple. So you're going to be able to use this video if you need to go back and review. If I went too fast for you in class, you can use this as a guide to help you as you complete your homework assignment. All right, so here we go. First of all, to calculate measures on line PQ, as you see on your display, says that point M is between point P and Q. So the first thing we have to do is make sure we know our location. So that means P, Q, and M are collinear. Remember, that is our vocabulary. Collinear means that they're on the same line. So we're going to keep reviewing that. So if we looked at these segments, and we would notice that the distance between P and M, if we added that to the distance of M and Q, it would give us the overall distance between P and Q. If we add the two segments together, they would give us the total length. So basically, we're just adding our numbers together. So the next thing we want to look at is we want to look at our line segment A, B, and C. That is also collinear, they're on the same line, but there's something special about this line. On line AC, AB is equal to BC, which means those segments are equal to each other. They're going to be the same distance apart. And there is a symbol that we use in geometry that lets you know that something is congruent. And that's a little dash mark that is right in between the lines. So you look at this line here in red, see this these two little dash marks? It's letting you know that the segment AB is equal distance from segment BC. They're equal to each other. So we also have a special name for this point that's in between. We call this the midpoint. Midpoint, halfway between something. All right, so it is important that we are familiar with congruent segments. Okay, we know that it's that little slash mark on the figure to let you know that they're congruent. So those are the two main things that we are going to be working on today. All right, so let's take a look at an example. All right, this example is also the example given to you in your notes. We're going to walk through it so that you can understand it better. Then we'll practice some. So the first one, find EF. So our goal is to find the entire distance between E and F. Well, what do you think you do? We're given the first segment of 1, 2. We're given the second segment. So obviously, we know that we would take 1.2, add that to 1.9, and that'll give us our distance of segment EF. That's pretty simple. So if you look down here, here's that exact work. The line segment ED plus the line segment DF gives us our EF segment. So all we have to do then is add 1.2 plus 1.9, and we get our answer. Okay, so line EF or segment EF is 3.1 centimeters. There's your answer. So that's not too difficult. Okay, let's go ahead. I'm going to scroll to our first example problem, and let's see if you guys can do this on your own. You can pause the video at this time, see if you can do these problems. We did these together in class, and then you can fast forward to walk through it if you need it. All right, so let's go ahead and take a look at the first problem. It says, find the measure of each segment, assume that each figure is not drawn to scale. We're going to find R to T. So first of all, we have to make sure we know what R to T is, and that's the overall distance. All right, so what do we do? Well, we're given the distance of RS, which is 2.0, and we're given the distance of S to T. We know that if we add those two distances together, they will give us our distance from R to T. So add those together, 2 plus 2.5 is 4.5. So RT is 4.5. Pull your label, centimeters. All right, hope you did well. That one was super simple. All right, now the next one is going to incorporate fraction work. So it is important that we do know how to do our fractions, and we know how to convert fractions if need be. All right, so in this one, we're going to find the distance of BC, a smaller part. So we know the overall answer is going to be 6. And how do we get to that 6? Well, we add the two smaller segments together. So we're going to add 2 3/4 plus whatever BC is. So what can we do to make that a little bit easier? Well, what's the opposite of adding? We can subtract. So let's see if I can move this so it's not on our screen. I'm just going to have to kick it down this way. Okay, so we can take 6, the overall distance, subtract that from 2 3/4, and that'll give us our distance of BC. All right, 6 minus 2 3/4. So in order to subtract a fraction, we need to pull a fraction out of the 6. So every fraction can be pulled out. We can pull out a whole numerator and denominator. They're exactly the same because 4/4 would be equivalent to 1 whole. So we're going to pull that out of the 6. That should be reviewed from previous work with fractions. And now we just simply subtract. Subtract your whole numbers. 5 minus 2 is 3. And subtract your numerators. 4 minus 3 is 1. And the denominator stays the same. 3 1/4 inches is your answer for the second one. So making sure you do know how to change your fractions is going to be important. One thing I want to also show you is what happens if you get measurements with different measures. Let's say I have one thing that's measured 1/4 and another thing that is measured in 6, and I need to change it to 16 so it's consistent. Remember, you just set up your proportion, and you ask yourselves, how do I go from 4 to 16? I times 4. Therefore, you also times your numerator by that. So 1/4 is equivalent to 4/16, and then you can use that 4/16 in order to do your adding and subtracting. Because remember, in order to add and subtract fractions, you've got to have common denominators. So hopefully that'll help you a little bit more when you see that problem on your assignment. All right, let's keep going. Now, in this next example, we start getting back into our algebra roots, which is great because algebra, we love algebra. Algebra is awesome. We can do it. It's simple algebra equation work. Let's see and how that would be set up. So in this one, as you notice, they have variables in it, which is why it turns into our algebra conversation. And what we're going to do is we need to find now the value of x. We want to know what is that x value in order to make that whole entire statement true. Well, we do know that if we take a and b and we add that to the other segment, BC, we know that we're going to get the overall equals 2x, or I should put that, equals AC, the whole entire thing. All right, so that's our first, making sure we understand our formula, what we need to do. All right, next thing is to replace it. Well, our x is going to be replaced with, or our AB is going to be replaced with x. Our BC is going to be replaced with 2x. And our AC is going to be replaced with 2x plus 5. So that's how we get our equation. X plus 2x equals 2x plus 5, right? X plus 2x will give us our overall, 2x plus 5. I'm going to put the extra math on the side just so that we can see it. Remember, the first thing we do is combine like terms. X's go with other x's. Remember, there's a 1 in front of there. 1x plus 2x is 3x equals 2x plus 5. Get your x's on one side. I'm going to subtract 2x from both sides, and I get x equals 5. There's my value for 5. If you take a look, there's my answer there. This is just showing you more of the work to get there, and then I can always double check by putting the 5 into the equation and making sure that it works. Okay, so there isn't a problem with algebra, so just make sure you just set up your proportions. Your two little segments added together equal the overall, and then just go ahead and combine like terms, move your variable to one side, and then simplify. So that's going to come in handy what happens when they don't give us a line to work with. So what I would do first when you see these kind of problems is we're going to find the value of x. That's our goal. Is I would draw out your line, make it visual. Okay, so we have point R and T, and S, it says, is in between for that information there. So I draw it out. Then once I have it drawn out, I can fill in the measurements. From R to S is 5x. From S to T is 3x. And from the whole entire line is 48. That's pretty simple. Fill out your equation. 5x plus 3x, those are the two small segments, equal the long segment, the overall. Combine your like terms. 8x equals 48. Divide by 8. Divide by 8. And x equals 6. And there's your value of x. All right, go ahead and pause and go ahead and try doing number 6 all by yourself. All right, we're going to go through number 6 then real quickly. Draw your line. Same thing, R, S, T. RS is 6x, ST is 12. The whole thing is 72. So we have 6x plus 12 equals 72. Get your variable by itself. 6x equals 60. Divide by 6, and x equals 10. Simple as that. So we're able to find distance even algebraically if we're giving variables. All right, and the very last thing again is to talk about that congruent. This slide just reminds you that this would be what the congruent symbol looks like, that they're congruent to each other. It's an equal sign, a little wavy sign over the top. And if you saw them on segments, there'd be these little lines here that would tell you that they are congruent to each other. So that's what we want to look for. So in our two examples, let's take a look. Are those two segments that I'm giving you, are they congruent? So let's take a look. AB and CD. Are they congruent to each other? So really I'm asking myself, is segment AB equal congruent to segment CD? And if you take a look, I have 5. Is 5 congruent to 5 centimeters? And the answer is yes. They are congruent. Okay, go ahead and try the last one on your own. Let's take a look. Hit play. XY and YZ. Well, the first thing when I look at this one, I could set up an equation. I'm not asking to solve for x, but I could solve for x, plug them back in, and make sure that my signs are that these sides equal each other. But I don't even have to do any math on this one. I mean, technically I could. I could do this problem right here, because if they were equivalent, or if there was a value for x, I can find what x is, and then I could plug x into both parts and end up with a number, and I can tell if it's congruent that way. But guess what? We talked about that symbol, right? Take a look at this triangle. There are two sides that are congruent. Look at this side right here and this side right here. What do you notice about them? They both have that little congruent mark. So those sides are truly congruent to each other. Does this side right here have that mark? There's no mark on it. So therefore, X, Y, and YZ are not congruent to each other, no. So this one's just basically a symbol problem. Are the symbols give it away whether they're congruent or not? No symbol, not congruent. All right, so your job is to finish the practice worksheet. Use this as a guide if you need to. If I went too fast, go back and refer to this. And then on Monday, we're going to cover how do we find distance on a coordinate grid using the distance formula on Monday. All right, see you guys later.